All right, let's talk dewatering. Today, we're putting on our detective hats and solving some of the biggest mysteries you face out in the field. If you've ever wrestled with a process that just won't cooperate, you know exactly what I'm talking about. So let's get started.
Sound familiar? You look down and your cake is more like a soggy mess. You know that means your hauling costs are shooting through the roof. Or maybe you're seeing those solids sneak their way back into your plant, which puts your entire permit at risk. These are the classic signs of a dewatering process that's crying out for help.
But here's the good news. The clues to fix it are right there in front of you. In this explainer, we're going to break down the evidence and give you the real-world actionable steps to troubleshoot two of the most common pieces of dewatering equipment out there.
Okay, first things first. Let's get really clear on our two main culprits. These are the fundamental problems that are behind pretty much every dewatering headache you're going to face.
So on one side, you've got low cake solids, or what we all just call wet cake. You're basically paying a premium to haul water, and that's just money straight down the drain. Then, on the other side, you have poor solids capture. This is a sneaky one. It's when solids escape and get sent right back to the head of your plant, creating this never-ending loop of problems that can mess up your entire operation. Both are expensive, and yeah, both are totally fixable.
Let's dive into our first machine, the belt filter press. The easiest way to think about this thing is like a giant industrial-strength wringer washer. Its one job is to squeeze that water out of the sludge.
And it does this in three main stages. First, in the gravity zone. A lot of the easy water just drains right out. Then, it hits the wedge zone, where two belts start to gently apply pressure. And finally, it goes into the high-pressure zone, where it's squeezed between a bunch of rollers. Understanding these three zones is the key to figuring out where things might be going wrong.
So, let's tackle case number one. You're getting wet cake off your belt press. You've got to start your investigation somewhere, right? So what's the very first clue you should be looking for?
It is the color of your filtrate. That's the water coming off the belt. This is your number one piece of evidence. I'm not kidding. It tells you pretty much everything you need to know about your polymer dose, which is almost always the prime suspect in these cases.
And it really is this simple. If your filtrate looks dark or black, it's full of solids. That means you're underdosing your polymer. If it looks milky white and maybe even a little slimy, that's pure excess polymer. You're overdosing. It's such a simple but powerful diagnostic tool that you can use every single day.
Okay, so you've checked the filtrate and you've dialed in your polymer dose, but you're still getting wet cake. What's the next clue? Well, now it's time to investigate the belt itself. You have to ask, is it even letting the water through?
This is what we call belt blinding, and there is a super easy test for it. Seriously, just take a bucket of clean water and pour it onto a section of the moving belt. If that water just pools up and rides along instead of draining right through, your belt is blinded. It's clogged. The solution is pretty straightforward. Get those wash boxes and spray nozzles working overtime and give that belt a really good cleaning. Now, if your polymer is good and your belt is clean, it's time to look at the machine's settings. Is the belt moving too fast? Try slowing it down a bit. That gives the sludge more time under pressure. Or maybe there's not enough tension? Crank it up to get a better squeeze. These simple mechanical adjustments can make a world of difference.
All right, we've cracked the belt press case. Let's move on to our next piece of equipment, the centrifuge. You know, if the belt press is a wringer, the centrifuge is like a spin cycle from another planet. It uses incredible G-forces to violently separate the solids from the water.
Now, to solve any centrifuge case, you have to understand one critical concept: differential speed. Just imagine the centrifuge has two main parts spinning at almost the same speed. There's the big outer bowl and then an internal screw or scroll. That tiny difference in speed is what pushes the solids out. So the bigger the difference, the faster the solids get kicked out, which means they have less time to dewater.
So let's apply this to our wet cake problem. If your centrifuge is spitting out wet, sloppy cake, the very first question you should be asking yourself is about that differential speed. Could it be set too high?
And here's why that matters. A high differential speed means that internal scroll is just pushing the solids out way too quickly. They simply don't get enough retention time under all those G-forces to properly dewater. The solution? You guessed it, reduce the differential speed, slow it down.
So just remember this simple relationship. A high differential speed means not enough squeeze time. The solids are in and out of the machine before the water can really be slung off. It's a fundamental relationship you gotta know.
But what about the other side of the coin, poor solids capture? You're going to look at the exact same setting, but now you're asking the opposite question. Is my differential speed too low?
See, when the differential speed is too low, that scroll just can't get the solids out of there fast enough. The bowl literally starts to fill up with dewatered cake, and those solids have nowhere to go but to spill over into the liquid, contaminating your centrate. It really shows you what a delicate balancing act centrifuge operation can be.
So the big takeaway here is that a low differential speed creates a solids overload and spillover. It's like a traffic jam inside the machine. The dewatering is happening just fine, but you can't get the cake out the door fast enough, and everything backs up.
Whew, we've gathered a lot of clues for both the belt press and the centrifuge. So now, let's wrap this all up with the 2 golden rules for any dewatering investigation. These apply to pretty much any machine you're running.
Rule number 1 is simple. Master your polymer. As we've seen, the color of your water, your filtrate or centrate, is the single most powerful clue you have. If you can get that polymer dose just right, you've solved half your problems before you even have to touch the machine. And rule number 2, manage your throughput. Look, when things start to go haywire, don't just run over and start twisting knobs and pushing buttons. Your first move almost always should be to slow down the sludge feed rate. Just give the process a moment to breathe and stabilize. Then you can figure out what's really going on.
So there you have it. You've got the clues, you've got the techniques. Now the question is, armed with this little field guide, which piece of evidence are you going to look for first to crack the case on your next shift? Thanks for tuning in, and happy troubleshooting.